Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to start the series of product rule. So I know that in my channel I have been talking about different rules, and in this particular video we're going to be doing an introduction to product rule. I'm going to be giving you a breakdown and analysis of the product rule, what a function that would require product rule to differentiate will look like, how to apply the product rule, and basically the step-by-step, basically a good detailed introduction, inshallah. So we're going to be talking about product rule, like I have said. Product rule for differentiation. That is what today's topic is about. Okay, so the first thing you have to know is, what do you understand in math whenever you say, what is the product of 5 and 8? If you remember from elementary school, from primary school, you know that anytime you talk about product in math, you always involve multiplication. Always. So if I say, what is the product of 5 and 8? You're going to know, oh, that's your trust trying to tell me to multiply 5 by 8, which is basically 40. What is the product of 10 and 10? I'm just telling you to multiply 10 by 10 together, and 10 by 10 is basically 100. So the same thing here. Product rule for differentiation, break down the language is asking you, is basically talking about product rule. That means this is a situation whenever you find that a function has two subfunctions that are multiplied by each other. So product rule involves multiplication. So basically this is what it is. It's nothing super wow. This is basic math that we've been doing since elementary school. So whenever you have a product rule, the functions tend to look like this. So this is y of x, and then this is at the subfunctions. F of x, right, multiplied by g of x. Now, in elementary school, anytime we talked about multiplication, this is what we tend to do, right? We do this cross sign, and this used to signify a multiplication symbol. But in calculus, many times, instead of using this x, especially because a lot of the x symbol is used, a lot of professors tend to just use the dot. So anytime you see a dot, this dot is not a decimal point. This is basically a multiplication symbol. So in product rule for differentiation, this is basically when a function has two subfunctions that are multiplied by each other. So how do we now differentiate two functions that are multiplied by each other? That is when we know that we're going to have to use the product rule. So anytime in calculus that you're given a question where two functions are multiplied by each other, just know we're supposed to just use the product rule. When I mean by two functions, you're going to see from the more videos that come with this series what I'm saying, right? You're going to understand what I'm saying when I start to do problems, inshallah. So that's the goal. So now this is what the function looks like, right? Right here. This is it with this beautiful arrow to the side. That's really what it looks like. Now let's imagine that this y of x, right? F of x multiplied by g of x. Now we're going to differentiate this. And what do we do whenever we differentiate? We differentiate the function with respect to x, or we differentiate the function with respect to the variable. In this case, the variable the main variable is x. So imagine if this variable was, say, like f. Sorry, let's not use f. Let's use a different variable. Let's say this variable was, say, m, and you have y of m, f of m, g of m, right? We're going to be differentiating this function with respect to m. I wanted you guys to know, because people are so used to differentiate with respect to x that even when they're given a different variable, say m, say s, say p, say q, they're going to be differentiated with respect to the wrong thing. That's not what we're doing here. We're going to differentiate with respect to the main variable. So I just wanted to explain that. So say our function was f of k, right? Multiplied by g of k, right? If we want to differentiate, we're going to differentiate this entire function with respect to k. That's basically what I'm saying. But that's a side note, but it's an important side note, because when you get to an exam and your teacher decides to give you a question or in an assignment where the variable is not x, I don't want anybody to make that mistake of differentiating with respect to x when a completely different variable is required, inshallah. We don't want to be making mistakes that can be avoided. We're mathematicians, and it's already a lot for you to be able to kind of break down the information. You don't want to be putting yourself in situations where like mistakes that you can avoid are made, you know. So that's it. So now let's do differentiate this with respect to x, right? So f of x multiplied by g of x. So here we're going to put d dx. Now I've written it as d dx. Let me show you another way we can do this. You can also say this process can also be written, in case you have another professor that prefers to write it like y of x equals f of x, right, multiplied by g of x. Just basically the same thing. If your professor then puts a prime sign, or your professor uses a d dx, it's just trying to tell you the same thing. This first process here with the arrow is just the function itself. Okay, important for you to know. These two ways here are not just the function, these are also what the function will look when it is the first stage of differentiation. So this is the first stage of differentiation, when you're trying to introduce the function to differentiation, or basically introduce the function to the beginning of the product rule. You're gonna see it with more problems. So first differentiation step. Yay! So that's nice. And let's go to the next page. So the next page now, let me say a really nice background. So this next page now, we're going to write the same exact thing we had. I'm going to be using a different one. Give me a second. So we're going to have y of x equals f of x multiplied by g of x, and all of this prime. So this is the same thing. Since this is a differentiated one, like I said, we could also have it as d over dx, and all of this y of x equals f of x g of x, right? Differentiating all of the with respect to x. And this is what you get. The way this is done is basically then you get f of x, right, prime. So f prime of x. So this is trying to tell you that the f of x function, which is a sub function, right? One of the functions. Remember, it's a product rule. We're multiplying two functions together. So what we do is we first of all differentiate the first function, then we multiply that whatever we get differentiated first function with just the second function that is undifferentiated. Okay, then we now do plus, we do g prime of x, the second function that has been differentiated, right, multiplied by the first function that has not been differentiated. So basically we're going to differentiate the first function, and then you leave the second function. Basically this is what we did right here. We differentiated the first function, like I'm using the yellow to underline it, but we left the second function, and then we multiplied the second function by the differentiated first function. Then we put that in a bracket, put it aside, then we do added that quantity plus g prime of x, which is the second function, differentiated, but then leaving the first function undifferentiated. So that's it. And the thing is, because of how math is, where basically, let me give you an example. 5 times 3, right, plus 4 times 6 is the same thing as saying 4 times 6 plus 5 times 3. So this is not a hard and fast rule. We just try to do it because of consistency. What I'm trying to explain to you right here is that the same way we can differentiate the first function, right? And then we leave the second function. Then we put that in a bracket together like we've done, as I've shown you here. And then we decide to differentiate the second function, and then we leave the first function. Is the same way we can do it both ways. So basically what I'm saying is that we can decide to do this right here. We can decide to get d of the x right here, y of x, right, equals f of x prime g of x. Guess what? We can also do this. We can say, oh, well, this is product, is multiplication. We can always just do g prime of x, okay, multiplied by f of x. Guess what? We did not change the position. We did not change the position of f or x. Since we can add both sides together, it's an addition, we don't have an issue. So this is 1 here, right? Plus, we can also then say f prime of x multiplied by g of x. And this is another one. Okay, see? Same exact thing. So don't ever get scared in an exam when you feel like, oh my god, like what's going on? I was supposed to differentiate the first one and multiply it by the second one that is undifferentiated, and then put that in a bracket and then add it to differentiating the second one and then multiply it by the first one undifferentiated. No, you can switch it. You can switch it, because if we decide to do, say, 5 times 2, right, plus 5 times 2, right, times 4 times 6 is gonna be the same thing as saying 4 times 6 plus 5 times 2. The answer is gonna be the same. See, 5 times 2 is what? Is 10. 4 times 6 is what? Is 24. 4 times 6 is what? 24. 5 times 2 is what? 10. 10 plus 24 is 34. 24 plus 10 is 34. And you're gonna get the exact same thing. So there is no issue. What you're doing is great. 100% fine if you decide to switch positions. So that's it. Now that we've talked about all of that, let me give you guys an example, and inshallah we're going to be able to handle more questions in future. So yeah, now let's do an example. Say we're given a question. I'm gonna write the question in yellow now. Y equals, sorry, not even y, right? Let's do y of x, because that's what we're working on. We're going to use the variable x. You guys will see when the question is reading completely. So y of x equals 1 plus 2x squared and x minus x squared. Now, when you first of all see this, as someone who is doing math frequently, one thing you should know is, first of all, these two things are in bracket. So the first thing you're supposed to understand that this is actually the product rule. Both sides are in bracket. Is trying to tell you that both stuff in bracket, both quantities basically in bracket, are kind of separated. They're almost their own individual thing, but they are still together within the function, right? So 1 plus 2x squared in bracket, and then the next thing x minus x squared. They're still, both of them combined is our function. Even though 1 plus 2x squared is sub function, meaning it's like a function within a main function. And so this is, say, sub function 1, and then this one right here is subfunction 2. What both of them have in common is that they are both multiplied by each other. So we're going to see with our brain, and with enough practice, you're going to be able to see it. This is one of those things where nobody can really teach you exactly. You're going to see it with more practice. So we're going to imagine there is a dot here, and this dot, like I said in calculus, signifies a multiplication. So basically what you're trying to tell you is to differentiate this. So the first thing you do, like I explained, the first step, see y of x differentiated, right, is equals to f of x prime g of x. Make sure to always write this rule, especially if you're new to this, so that you can do your math properly. Same thing as f prime of x multiplied by g of x left by itself, all of that in a bracket, plus g prime of x multiplied by f of x by itself. There's a dot here, and that's it. And that's really what you need to do. So basically what is going to happen now is we're going to apply that same understanding to this question. So let's go to the next page. You can see my notes are quite detailed, and please try to make your note detailed as well, in order for you, so that whenever you're put in a position where you have to go back to your notes, you're not confused. 1 plus 2x squared multiplied by x minus x squared. So this is our function. Now we're going to try to differentiate this. So y of x equals 1 plus 2x squared and x minus x squared. What are we going to do? We're going to differentiate it. So I put the prime here. What this is just trying to tell me to do right here would be, first of all, like I said, since we're using the previous page, this right here, I would advise you as a student that is just learning, especially if you struggle with calculus, is to substitute what all of these things are, and should be able to know and different, and to be able to to be able to substitute it, right? So in this particular case, we have this, and we know that this is basically this f of x, and then there's g of x, right? So this is what I will tell you to do. So f of x in this particular case, we're going to put that to be 1 plus 2x squared. So that's f of x, and g of x is going to be the second one I'm underlining here. That's going to be x minus x squared. So this is it. So now what you're going to do now is, now that you know what the rule is supposed to look like, right? F prime of x and g prime of x, you need that. You can either make like a side note here and do your f prime of x and differentiate it up front, and you do your g prime of x and differentiate it up front. You can do that, or you can just differentiate it as you're solving. I like to differentiate as I'm solving, but in order for it to be easier for people, I can do both. So I'm going to do both, inshallah. So here would be 1 plus 2x squared. Now, 1 plus 2x squared prime, right? Since we're doing f prime of x. And please, if you don't know the power rule, go and review the power rule. Pause the video right here. Go to my videos that have power rule and go and watch them. Or go back to your class note and review the power notes, power rule. If you don't know the power rule for differentiation, it's not going to be the easiest thing for you to understand. Power rule is not difficult, but inshallah, you're going to get it. So f prime of x, 1 plus 2x squared prime. So I'm going to use this style. So f prime of x, that would be differentiation of a constant is always going to be 0. So this 1, differentiation of 1 is going to be 0, plus differentiation of 2x squared is just basically us dropping the exponent of x, or the power of x, basically doing the power rule. We drop it and multiply it by the coefficient of x squared. So the coefficient of x squared here is 2, like I have underlined here. So we're going to drop this exponent power here. We're going to bring it down here, multiplied by 2. So at the end of the day, we get a 4x, right? 4x. And we're going to decrease the exponent or power of x, which is 2 by 1. So that would be 4x. So f prime of x becomes 4x. Yay. Now we're going to do the exact same thing we've done now for g of x. And I hope I'm not confusing anybody. I'm going to do it twice. So hopefully you're going to understand it. G prime of x is basically x minus x squared prime. So now g prime of x. So we're going to think, you guys, what is the differentiation of x in this case? That's 1. What's the differentiation of negative x squared? First of all, we can just put the negative up front, which is the negative in front of x squared. So when we differentiate x squared, what would we do? We just drop the power of x here. Like I said, please review your power rule. Drop the power of x and make it the coefficient of x. So basically we're dropping 2 down. So that becomes 2x, but then we're going to decrease the power of x, which was 2 by 1. So that would now decrease it to 1. So basically this is it. This is it. So g prime of x, I'm going to put it in blue. G prime of x is 1 minus 2x. And f prime of x is just 4x. So now we have both. Now we can go back to the previous page. What did the previous page say? To do differentiation rule, we're going to do f prime of x multiplied by g of x plus, which is the first side, plus g prime of x multiplied by f of x. So now that we know that, let me put that here. I'm going to use a different color. Same thing as saying f prime of x multiplied by g of x. So a big bracket to make them separate. So g prime of x multiplied by f of x. So now what we're going to end up is f prime of x. What's f prime of x? 4x, right? Multiplied by g of x. X minus x squared plus, what is the, so you guys, when I say f prime of x, what did I do? Please don't forget, f prime of x, I went to go get the 4x right here. I put it right here where I'm underlining, and that's f prime of x. Then I went to g of x. G of x is basically, what is g of x? We know that to be x minus x squared. So that's that one. Multiplied both of them together. And then you have g prime of x would be 1 minus 2x, right? And then do that, and then you multiply that by f of x. That's 1 plus 2x squared. Yay! So that's it basically, and that is what we have here. So when you can do this style where you're going to first of all use the product rule. First of all, you first of all look at a question. You see whether you're going to apply the product rule or not. When you know you're going to apply the product rule, you know that it has to be 2 subfunctions. And again, you can also do product rule whenever there are 3 subfunctions, but that's a whole different video. We're going to just stick to 2 subfunctions, which is more common than the 3 subfunctions. That is also that's where you have 3 different functions and you do the derivative of 2 functions and you ignore one, and then you have another 2 functions and you don't ignore one. But that's not what we're doing. We're going to stick to this one so no one gets confused. So we're going to do differentiation of the first sub. You're going to first of all determine, do I need to use the product rule? Yes. If you need to do the product rule, put the first step of what a product rule is supposed to look like, which is what I'm showing you right here. This is the first step. When you put the first step, then you go back to your question and you're going to identify from the question I am given in the exam or in an assignment, what can I note? What is the first subfunction? What is the second subfunction? Okay, you put them aside like I have done in this like yellow lined area. You do that in a corner. So you do the f of x, then you find the g of x. Oh, it's like, okay, I know my f of x, I know my g of x. In this case, f of x is this one right here in yellow, and g of x is this one right here in yellow as well. I'm doing for the beginning. When you do that, then you do the differentiation of one of the f of x on one of the subfunctions, sorry, and then you do the differentiation of the second subfunction. When you can do that, you can now combine all of them. I think this is very easy for students, especially students who struggle. I do the other way where I just solve it in. That's what many people, when you practice so many times, you become more confident that you can just solve it in. So that is it. Now that you do that, 4x, so now you now have 4x multiplied by x minus x squared. What are we doing here? We just do 4x, right? And you multiply it by 4x times x, and then you do 4x times negative 4x times negative x squared. So 4x times x. If you guys, by this time, you're supposed to be able to know how like multiplying variables work. So that would be 4x. Oh, so you have a variable x and a variable x. Both of these variables have the power of 1, because anytime you have a variable by itself, like x, right? The variable, like, so for example, the exponent or the power of variable x of any variable is 1. The power of x squared is 2. The power of x cubed is 3. The power of x to the 4th is 4. So in this case, whenever you have two variables of the same power, when you combine them together, you have that one variable, and then you just add the power. So in this case, the variable here is of x is 1. The variable is on. When you combine, multiply, that will become 4. 1 plus 1 is 2, so it becomes 4x squared. This is very elementary stuff, but I'm just mentioning it as a way for you to be able to do a good refresher. So minus 4x multiplied by negative x squared, that will be 4. X times x. So now you have this power, so you have a power of 1 here, and you have a power of 2. You add them together, so you have negative 4x cubed. So that's here, that's the plus. So now you have the next thing, which is so the next thing that we have here is going to be, so you have this one where you have so you have 1 times 1 is basically 1. I don't know, I was a little bit distracted. 1 times 1 is 1, so you have this, and then 1 times 2x squared will be plus 2x squared, so basically the exact same thing. So now you have negative 2 here times 1 here. Negative 2x times 1 will be negative 2x, and then negative 2x times positive 2x squared, that will be negative 4x cubed. Yay. So basically what we have now is that we're just gonna add them together. So we're gonna end up with, let me use a different color, maybe black. So we end up with 4x squared minus, now we can ignore the brackets, minus 4x cubed plus 1 plus 2x squared minus 2x minus 4x cubed. Negative 4x cubed and negative 4x cubed be negative 8x cubed. Okay, so that is gone. So this is gone and this is gone, and so we're done with those two. Now 4x squared plus 2x squared is the same thing as plus 6x squared. So basically this is gone and this is gone, and then you just add the rest of it. So you have negative 2x left and then plus 1. So this is basically the answer. The answer is negative 8x cubed plus 6x squared negative 2x plus 1. So that's basically the answer, you guys. All the work done is that. So now I already promised, and I don't want to break my promise, that I'm going to do it both ways. So now I'm just going to do this whole problem again, but this is for students who already have a good grip in math and they don't want to do the breakdown method sideways that I have here in this yellow and black gorgeous looking box. So let's go. Let me do something different just for the sake of like already promising it. So basically we have the question y of x equals 1 plus 2x squared multiplied by x minus x squared. So now we're doing the product rule. We get the point. That's where the dot comes from. And also these are two sub functions that both in brackets and they're separated. So basically it's a product rule. It's a given. I'm not saying that is what all functions that would require applying product rule looks like, but in this case that is the case. So in this particular case, we already know when we do when we derive it, when we do the differentiation, right? So x minus x squared, and we do the differentiation d over dx. So basically, so this is basically it. You can now have so now this is basically it. So you can now remember what I said. We can go back to what was explained, f of x and g of x. So here we have that. So this is going to be one of the functions, so f of x here, and then g of x, right? So basically what you're trying to say is that we're going to do the differentiation of one and then leave the other, put that in bracket, plus differentiation of the second one and then leave the first, and then just add them together, and that's your answer. So, but that's the quick way. But then let me explain it. So now we're going to have to do, let me use black. So that would be 1 plus 2x squared prime multiplied by x minus x squared plus x minus x squared prime multiplied by 1 plus 2x squared. And I'm going to explain this a little bit more. So this is the more direct method rather than, remember what I did here? This one had like in the box, the black and yellow box, I first of all did the differentiation side by side and then put it in, like inputted it. Or this one, you can just know in your head, okay, this is f of x, this is g of x. I'm going to differentiate the first one multiplied by the second one that is not derived, put all of that in bracket, and then differentiate the second, and then you did plus, then you do the then you just do the differentiation of the second one while you leave the first one. So here this is the case. So let me rewrite it again because there's no harm in doing that. So it'll be 1 plus 2x squared prime x minus x squared, all of that, plus x minus x squared prime 1 plus 2x. So basically, what's the differentiation of 1 plus 2x squared? We already know that differentiation of 1 is 0, so we'll just have 0 plus, and you don't have to write 0, you can ignore it, but I'm doing it because it's an introduction video. In more videos, I can ignore that. So what's the differentiation of 2x squared? By this time, if you've done the power rule, you just know that's going to be 4x, right? Multiplied by x minus x squared plus, what is the differentiation of x here? That'll be 1 minus, now what is the differentiation of negative x squared? That's just basically negative 2x right? So multiplied by just that 1 plus 2x squared. Sorry, I forgot the squared here. That's a nice catch because we don't want the answers of the previous page and this new page to be different. So here is just basically stuff. 4x multiplied by x minus x squared plus 1 minus 2x 1 plus 2x squared. So that would be 4x squared minus 4x cubed plus so you have plus 1 times 1 is 1 plus 2x squared. Basically, when you do 1 times 1, 1, and then 1 times positive 2x squared, that's another 1, minus negative 2x times 1 is negative 2x, and negative 2x times positive 2x squared, you know that negative times a positive is always going to give you a negative, times negative 2x squared. So 2x times 2x squared now would be, what's that gonna be? That's gonna be 4x cubed. Now we can ignore all of the brackets and stuff. So basically, we have 4x squared plus 2x squared. What's that gonna give us? That's gonna give us 6x squared. Okay. Next thing, negative 4x cubed plus, because there's a plus here in front of the bracket, plus negative 4x cubed, that's gonna give us negative 8x cubed. Okay, then we have negative 2 by itself, and we have 1 right here, so that will be your negative 2x. Sorry, we have negative 2x and we have 1 plus 1. So basically this is the answer. So we can just have this here as negative 8x cubed plus 6x squared negative 2x plus 1. So that's your answer basically. And if you go to the previous page, it's the same exact thing. The only difference is I did the differentiation and everything, and then I just substituted, multiplied, and did it. When this one is more direct, I did the whole solution within the steps, while this other one I did a box step aside of all the differentiation, and I just inputted it or substituted it and just did that. So I hope this video was helpful. Inshallah there'll be more of these videos. May Allah subhanahu wa ta'ala make it easy for me to be consistent, I hope, because it's very important. And I just wanted to tell you guys, please send your feedback in the comment section. Basically send me your feedback in the comment section. You have a different way we can do this videos, you can suggest it. Currently I do not have somebody who's going to be helping me edit my videos. That's probably the reason why I'm not as consistent I would like on YouTube. But please, if you know anyone who is a really good video editor, you guys please let them email me. My email is going to be in the description box. I literally want someone to edit the videos, make them look really good, beautiful intros. I do them myself, but I don't always have time to do them. So I would like somebody who would be willing to do them. Obviously it's going to be paid. So if you know how to do them yourself and you don't mind payment, it's going to be super simple and all of that stuff, you can email me as well. So I hope this video was really helpful to you guys. May Allah subhanahu wa ta'ala make it easy for you. May God help you with it. So I wish you guys all the very best. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.